Graph traversal. What is a graph? A graph is a collection of nodes called vertices and a collection of segments called lines which connect the pair of vertices. A graph can be directed or undirected. A path is a sequence of vertices in which each vertex is adjacent to the next one. In an indirect graph, you may travel in either direction. A cycle is a path consisting of a last three vertices that starts and ends at the same vertex. A loop is a special case of a cycle where a single arc begins and ends with the same vertex. Operations. There are six primitive graph operations that provide the basic modules needed to maintain a graph. Insert vertex, delete a vertex, add an edge, delete an edge, find a vertex, traverse a graph. Traversing a graph means to visit each vertex in a graph. Since each vertex in a graph can have multiple parents, it is more complicated to traverse a graph than to do the same with other data structures such as linear lists or trees. We have to ensure that we traverse each element only once. There are two standard graph traversal: breadth first traversal, depth first traversal. This is an example of visited and queue. This is an example of algorithm breadth search graph. Time and space complexity. Applications. Graph traversal is used to find the shortest path between two nodes. It is used to find neighboring locations in GPS systems. Depth first search. Depth first search or depth first traversal is a recursive algorithm for searching all the vertices of a graph or tree data structure. DFS uses a stack data structure which use the concept of LIFO, last in, first out. Any node can be considered as a root node unless it is specified. Algorithm. The DFS algorithm works as follows. Start by putting any one of the graph vertices on top of a stack. Take the top of item of the stack and add it to the visited list. Create a list of that vertex adjacent nodes. Add the ones which aren't in the visited list to the top of the stack. Keep repeating steps 2 and 3 until the stack is empty. From slide number 12 to 31, there is an example of DFS. This is code of DFS. This is output of the code. Time complexity. Big O of n plus e, where n is number of nodes and e is number of edges. Since we have to visit every node and examine every edge at least once, space complexity. Big O of n, where n is number of nodes. Breadth first search. Breadth first search algorithm or BFS is most widely utilized method. BFS is a graph traversal approach in which you can start a source node and layer by layer through the graph, analyzing the nodes directly related to the source node, Then, in BFS traversal, you must move on to the next level neighbor nodes. According to the BFS, you must traverse the graph in a breadth-wise direction. To begin, move horizontally and visit all the current layer nodes. Continue to the next layer. The architecture of BFS algorithm. We are allowed to use any node as a source node as per the law. However, in this case, we can use 0 as our source node. Then we can explore breadthwise and find the nodes which are adjacently connected to a source node. Then we must come down to the layer 2 and find the relative nodes that are adjacent to the layer 1 nodes. If you select alternative source node, this order will change. And that's how the straightforward BFS algorithm operates. The T diagram which is added below. Pseudocode of breadth first search algorithm. Example of breadth first search algorithm. Step 1. In the graph, every vertex or node is known. First, initialize the queue. Step 2. In the graph, start from source node A and mark it as visited. Step 3. Then you can observe B and E, which are unvisited nearby nodes from A. You have two nodes in this example, but here chose B. Mark it as visited and enqueue it alphabetically. Step 4. Node E is the next unvisited neighboring node from A. You enqueue it after marking it as visited. Step 5. Now A now has no unvisited nodes in its immediate vicinity. As a result, you dequeue and locate A. Step 6. Node C is an unvisited neighboring node from B. You enqueue it after making it as visited. Step 7. Node D is an unvisited neighboring node from C. You enqueue it after marking it as visited. Step 8. If all of these adjacent nodes that have already been visited, remove D from queue. Step 9. Similarly, all nodes near E, B, and C nodes have already been visited, therefore you must remove them from the queue. Step 9. Because the queue is now empty, the BFS traversal has ended. Thank you.